We have entered the post-antibiotic era. Now, this sounds pretty scary, right? Like it's the start of a sci-fi movie and the world is about to end. Well, it's not quite that dramatic yet, but it is still a very serious issue. Antibiotic resistance is present in every country around the world. Some bacteria are resistant to all current antibiotics. And without antibiotics, things like organ transplants, chemotherapy, C-sections, and even a scrape on your knee could kill you. So, for my PhD project, I aim to design a new broad-spectrum antibiotic. Now, how do you even design an antibiotic? Well, there's a few ways you can go about this. The approach I'm using is called rational design. This involves knowing what you want to target in bacteria, how your target functions, and how you could possibly inhibit this function. I am targeting signal peptidase, or the red rectangle, which is responsible for the export of the majority of bacterial proteins, or green circles, from the inside to the outside of the cell. Signal peptidase is essential for survival and is found in all bacteria. For the past year and a half, I have been studying what signal peptidase does and does not export efficiently. The sequences that are processed slowly, or not at all, have the ability to block or to drastically reduce the rate in which signal peptidase can export proteins. These slow sequences are what I am using for my rational drug design. Now, to understand how my drug will work, let's imagine that we're currently experiencing the zombie apocalypse. So you're at home and the zombies are on their way. How are you going to stop them from getting in and eating your brains? Well, first things first, you need to block the door. What are you going to use to do this? A table, a chair, a couch? Whatever you use, you have to make sure that you block the door and to keep it blocked long enough that the zombies will eventually go away. So, these green zombies need to make their way through the barrier of the red door to get into the house, eat your brains, and expand their zombie gang. Just like in bacteria, these green circles need to make their way through the barrier of the red rectangle for the bacteria to survive and to kill you. Now, if we block this red door, the bacterial proteins can't get to where they need to go, and the bacteria will die, and you will survive. So far, we've tested a few couch-like drugs and seen that we're able to block this door well and for a long time, and are now testing the next round of designs, which aims to help in getting the drug to the door. With further development of these drugs, hopefully we'll be able to keep this door shut, overcome the resistance to antibiotics, and no longer be afraid to scrape our knees.